Uh, Good afternoon. Thanks for coming to this talk. My name is Yong Tang. I'm a maintainer of CoreDNS project. In today's talk, I'm going to mostly focus on the introduction and deep dive of CoreDNS project. This is my profile and my GitHub page. By the way, if anyone has any questions you want to ask, you can always reach me at GitHub with my GitHub handle, Yong Tang. So I should be available most of the time on GitHub. Okay, so this is the agenda for today's talk. So first of all, I'm going to introduce about CoreDNS project and some of its history and its functionalities. I'm also going to share the status update since last year. Next, it's going to be the discussion of Google Summer of Code involvement, which is one of the highlights of CoreDNS. At the end, I'm going to discuss about technical deep dive of CoreDNS. I'm also going to share a demo plugin, going to show you a demo, how to write a CoreDNS plugin in, let's say, 50 lines of code. Hopefully, anyone that's interested in writing a CoreDNS plugin can learn something and contributing from now on. Okay, first of all, CoreDNS. So what is CoreDNS? I guess most of people in this room already heard of CoreDNS as part of the project. CoreDNS is a flexible DNS server written in Go. It has a focus on service discovery. One of the nice features of CoreDNS is it's a plugin-based architecture, which means you could easily extend additional functionalities if you know how to write in Go. In other words, if you see any functionality that's missing and you know how to write Go, you can just grab your laptop and write several lines of code. Hopefully, you can come up with something that's going to be useful for you. CoreDNS is a default DNS server in Kubernetes now. We have been part of DNS release since Kubernetes 1.11, and in 1.13 we became the default DNS server. CoreDNS itself supports different protocols. We have support for DNS over TCP, over TLS, and DNS over gRPC. In addition to integration with Kubernetes, CoreDNS also has Route 53 DNS data sync-up. So if you deploy your CoreDNS in a Kubernetes cluster, you can actually wire up CoreDNS with Route 53 AWS backend. In this way, for any Route 53 change in AWS, it can be populated to your Kubernetes cluster. This allows easy integration of your on-prem deployment with your cloud deployment, and also allow a mixture of hybrid cloud deployment. CoreDNS itself is started and led by Mick Gibbon. When CoreDNS started, he used to work for Google, but now he works for another company. Actually, one interesting thing about CoreDNS is that when Mick started CoreDNS project, he actually forked the source code from Caddy HTTP. I mean, I'm not sure anyone heard of Caddy HTTP server before? Raise your hand. Yeah, that's great. Yeah, as you may know, Caddy HTTP is an HTTP server with a focus on HTTP 2. And Mick actually grabbed the Caddy source code and forked the source code. And even though Caddy has nothing to do with DNS, he somehow managed to make that happen to just change the source code so that it became a DNS server. So that's one interesting thing. That's also one of the good things about the Golang by itself, because CoreDNS is written in Golang. And with Golang, a lot of things are so easily programmed such that if you want to make any change, it's so convenient. So that's just some of the interesting trivia about the CoreDNS project. I want to discuss about the CoreDNS community. In CoreDNS, compared with some other projects like Kubernetes, CoreDNS has a relatively small community. However, our community is expanding, and we have a healthy 150 plus contributors at the moment. We have 14 maintainers, One thing about CoreDNS maintenance is that most of the maintenance by CoreDNS are actually not sponsored by a company. So we spend our spare time to contribute to CoreDNS. So that's a distinction between CoreDNS and other projects in CNCF. We also have 30 public adopters. Adopter means if a company or institution use CoreDNS and they want to share us with their name and make their name public, they can announce them as adopters. So of course we have much more users or much more companies using CoreDNS because of the Kubernetes integration. But so far we have 30 adopters. That's they allow us to use their name. So that's a good thing. And also we have 4,000 plus stars. That's no, in GitHub, that's probably the only thing that matters. By the way, if anyone feel like the CoreDNS itself is helpful and you want to help CoreDNS as well, if you haven't done so, you can certainly push a start button on GitHub. With respect to CoreDNS community, the most active one obviously is GitHub. Mick and me are available on GitHub most of the time. If you have any question, you can always ask questions on GitHub. We're glad to solve the issue. We also have Slack channel that's part of the CNCF with CoreDNS Slack channel. This one is less popular, mostly because nowadays you have a lot of ways to do the messaging. So people use like a WeChat here, like in the United States, people may use GitHub, may use Slack. So I cannot say you will find a lot of help from Slack, but that's also, it's one of the active channels that you can utilize if you want help. We have some other resources, but I'm not sure it's going to be very active at the moment. Since 2017, CoreDNS has participated with Google Summer Code program. That's a program sponsored by Google. Essentially, Google, for any student that hasn't graduated, if you're still registered in school, you can participate in Google Summer Code. Essentially, you'll complete a project in several months, and Google will pay you money during that period. So that's a nice return for both for you and for the community. As part of CNCF project, CoreDNS participate in Google Summer Code 3 years in a row. The first year we have contributors contributing to DNS tab. The second year we have contributors that actually have integration of etcd. And this year we have proposal accepted. I'm not going to announce his name yet because he hasn't finished the Google Summer Code. So next year I'm going to show his name here. By the way, if anyone in this room knows anyone else that has interest in participating in Google Summer Code, you can certainly apply that next year. And that's, like I said, that's a nice return for yourself if you're a student, because Google pays you money. It's also a good environment for you to be participating in the community. So I'm going to start with technical deep dive here. The first thing I'm going to discuss is service discovery with DNS. Then I'll update some of the Kubernetes use cases, because obviously CoreDNS itself gets a lot of popularity because of the Kubernetes integration. I'm going to show how queries are resolved. And finally, I'm going to give you a demo to just see how you can build a CoreDNS plugin in, let's say, 50 line of code. Let's see. So first of all, service discovery. As we all know, CoreDNS has a focus on service discovery. So a lot of people actually ask the question, in this day and age with software-defined networks, everything could be virtual. You have an IP, your IP, you can assign any IP you like in a virtual way if you deploy your networking. So why DNS is still an option, or why DNS still could be useful nowadays? So there are several reasons for you to use DNS, even though SDN can solve most of the problem. So first of all, DNS is very nice and flexible in direction. with this indirection, it allows you to stay away from future changes. For example, let's say you want to migrate from one cloud to another, and your servers may be forced to have IP address change. You don't want to disrupt your user experience because you don't want to tell every user, say, I'm going to make a change because I move from, let's say, AWS to Ali Cloud or from AWS to Google Cloud. In this way, if you have DNS as an indirection, you tell the customer, say, you continue to use the same DNS name, and we'll do the backend change, so nothing will be impacted. So that's the indirection you always want, because you never know what's going to happen in the next year or next 10 years, right? 10 years is probably too long, but even for next year, you could have lots of change for your service. Another thing is the DNS itself is very easy and simple. This is a protocol that has been there for so long, such as developers, DevOps, and IT admins, both all of them knows. So this is very important because you could introduce a new concept like SDN, but not everyone knows what SDN is. So with DNS, you can do a lot of things and talk to different levels and different communities. And this is very important for you when you try to deploy your service. And also DNS is a very stable and old protocol, which means it's very it has been there for a long time with your existing IT infrastructure. So your IT infrastructure may not be so advanced to know how to set up SDN, but they certainly know how to set up DNS. I'm pretty sure about that. So that's why you want to choose this protocol if you have a chance. Also with DNS, you could work with a hybrid environment. Like I mentioned, we have some integration of Route 53 Cloud Sync with AWS. So that means if you deploy something on AWS and you have another Kubernetes cluster, the information on both of them can be synced up and can share each other so that you can see where the service endpoint is. And finally, and most importantly, DNS itself is a distributed system in nature. It may not be the most sophisticated distributed system, but it still scales well. So if we have a very big system that has like thousands of nodes or even hundreds of nodes, with DNS, you can easily scale up. That's not something so easy. That's not something you can achieve with other solutions. Let's go to the next topic about update for Kubernetes. CoreDNS itself is part of the Kubernetes release, so anything related to CoreDNS might impact Kubernetes real. We are here for KubeCon, so I'm going to discuss about some of the changes that have an impact. So first of all, in Kubernetes 1.11 to 1.14, we use CoreDNS 1.2.6. There's some, unfortunately, there's some incompatible changes of CoreDNS which may impact things. For example, in CoreDNS 1.5, the health plugin itself has been replaced with health and ready. gRPC plugin has been introduced. Also, there are some other changes. For example, the multiple API server endpoint no longer supported. You can still, if you have a CoreDNS, talk to Kubernetes, and your CoreDNS is not part of Kubernetes cluster. You can still talk to Kubernetes, but it's not. You cannot talk to multiple API servers anymore. And also, the API server resync has been disabled. This is quite debatable, but the decision is that we want to move forward with disabled API server resync. Just for your convenience, that's a backward incompatible change. So if you're going to update to CoreDNS 1.5.0, you need to take notice of those changes that may impact your Kubernetes cluster. Okay. Let me see. So this is a diagram that shows how CoreDNS resolve query. So first of all, CoreDNS for each query, it's always based on the the root of your query domains. In this way, here you could see different domain names have different plugins enabled. Like for organization.com, you have arrows, cache, and forward plugin enabled. By default, you have a much larger list of plugins enabled, like arrows, health, Kubernetes, and also forward. When query comes in, first it's going to find out the suffix domain. That's going to see if it's a match. If it is a match, it's going to go through each plugin and traverse through the plugins one by one until one plugin decides this plugin is going to do the job. If this plugin do the job, it's going to return back, give you the query, and the process will stop. If the plugin captures the query and this plugin cannot figure out if it needs to process or not, then this plugin will essentially let the query to fall through to the next plugin. So next plugin will pick up the query and decide if they want to return or not. So that's a workflow of resolving a query in CoreDNS. Okay, now let's get to the point of demo. You know, everyone probably want to see some true demos nowadays. So the demo plugin is a very simple thing. It's essentially a source IP-based service discovery. We talk about service discovery. We talk about CoreDNS. So what exactly is service discovery? Service discovery essentially is a way to resolve an endpoint to IP address. But if you say I have a service and I know this IP is static, so that's not the point, because if it's one-to-one match, what's the point of having a map by itself? So here I'm going to show you why service discovery could have complications. Let's say you have a cluster, and your cluster has internal IPs and external IPs. Of course, when some of the node try to contact your service, it might be outside of the cluster. It might be also inside the cluster. If it's outside of cluster, it might contact the endpoint that's actually going to the public IP. If your node is inside the cluster itself, you probably want to assign a private IP. So in this case, as you can see, let's say you have a cluster with a private IP of 172.0.0/8, which is very common if you ever played with Kubernetes. Let's just do it this way. Let's say from outside. If a query is from outside, and your query is example.org, let's say for some testing purpose, we're just going to return your IP of 8.8.8. It may carry some meanings, but it's probably relevant. Let's say internally, if a node tries to query the DNS with a record of example.org, it's going to return a different IP address. Let's just assume it's 1.1.1.1. So that's a setup we want to demo in this demo plugin. By the way, the 8.8.8, that's the DNS server provider Google, and 1.1.1.1 is a DNS server provided by Cloudflare. They have different purpose and different strengths. I'm not going to discuss about which DNS server is a good one, so it's up to you to decide. So let's just go to the source code directly. So I'm going to walk through the source code so you could take a look and see how easy it is to write a CoreDNS plugin. So before you want to write a plugin, so first thing is you need to set up your plugin. To set up plugin is fairly easy. As you can see, there is an init function that's actually in Golang. Essentially, it's going to just bring this plugin up. You register yourself, which is a demo, and you register action, which is setup. The setup it's actually doing almost nothing except it just acknowledges that this setup captures the content of the core file, say I'm going to be responsible for demo plugin. So that's fairly straightforward, right? So now let's get to the CoreDNS. The CoreDNS is the main body of a plugin. With CoreDNS, you essentially implement this function to decide what you're going to do with the DNS query. As we can see here, CoreDNS passes a DNS response writer. It also passes a message. So R is the DNS message, that's a query message that you need to take a look and see what you want to do. Response writer is it's up to you to decide if you want to just return back to give the query the response, or you want to let the plugin let the plugin process to fall through to the next plugin. The first line, as you can see, is just to try to state equals request.request. This is just essentially just allow you to capture the state of the request. You get a queue name, that's a query name, and you can decide if you want to reply IP address. As we discussed here, you want to reply different IP address based on where the query comes from. If the query is coming from a private IP address, let's say 172, which means it's actually internal, or if a query is from IP address of 127, which actually means it's actually local query, we are going to return 1.1.1.1. Otherwise, we are going to return IP address of 8.8.8.8. The next line, as you can see, is just a printout. This printout is it's unnecessary, but for the demo purpose, we want to just print out something so you can see what's happening, right? So let's continue. So we get the first part process. The second part is essentially you can decide what you want to reply. Now, you need to construct a DNS packet, reply packet. The packet essentially is just you have a resource record of header with type A, and the class is an INET type. As we discussed, we have different IP address to be returned. So we just take the IP address and inject that into the response packet of a DNS, and we decide to return. That's actually pretty much it for a plugin. If anyone has ever played with CoreDNS, you probably know in order to set up CoreDNS, you also need a Corefile. The Corefile itself is also very straightforward. As you can see, by default, all plugins are disabled. If you want to enable any plugin, you just write a line. In our case, we have a demo, we just enable demo, and that's it. So we don't want to have any other configurations. Of course, if you have interest, you can dig deep into this, dig deep into the Corefile setup and see how play with the CoreDNS plugin. The next step, as we mentioned, we already have everything ready. The next step, of course, is how to build that. We have a source code of setup. We have source code of CoreDNS. We have a Corefile. Now the next step is to build a CoreDNS. To build a CoreDNS is also fairly easy. You add a demo column demo to plugin.config. This is all you need to enable everything. The next step is to compile. In order to help everyone and make the process convenient, there's one way to build a plugin that is to reuse the Docker. I mean, I've been with the Docker community for a long time, so I'm certainly more familiar with this concept. If you want to build of course, you can build your CoreDNS in a Golang environment, but in case you don't want to install Golang, or in case your Golang environment has some setup you are not feeling comfortable to mess up with, you can just install Docker. And as long as you have a Docker installed on your machine, all you need is just one line to compile that. See, if you look at this line essentially just grabs the Golang's 1.12 Docker image. And this allows you to run a command line inside the Golang And in our case, we are going to use make gen, which is going to generate the necessary generate additional files that's required to build a plugin. And the next step is make, which is going to give you the binary. And that should be it. If you run CoreDNS from your command line, that's all you need. So I'm going to escape the PowerPoint slide and show you the demo. So just to make it simple, I already set up a file here. As you can see, the one file is a plugin.config, which is essentially just one line change, right? That's fairly easy. Another thing is let's just add everything so we can see which file has been changed. I only add 2 files, right? The first file is setup.go. If you look into this one, yeah, that's straightforward, right? So how many lines? That's only 20 lines, right? So that's all you need to set up and register demo plugin. So next file, let's take a look. Okay, this is slightly more than several lines, but as you can see, it's still pretty much straightforward. We have a self-DNS, which is the main body of your process. The logic is quite clear, right? As I mentioned, by default, we are going to return 8.8.8.8. But if it's an internal IP, it's from an internal IP, from a private IP, then we're going to say, okay, let's just return a different IP address. That's going to be 1.1.1.1. So that should be it. So let's just run this command, see how we could build everything. Oh, okay, let me. Okay, yeah, it's actually building. So let's just wait probably like 1 minute to wait until the binary has been built, and then I'm going to show you use dig to see how to query that from internal and external interface and see how different IP addresses are being replied. Okay. I already opened 2 windows here. One window is actually part of the machine. This one is on the same machine as the machine I'm building. So you could consider this one as an internal node. And I have another machine. I have another window that's actually to my laptop. Of course, this one is external, right? So ideally, if I'm going to set everything up, we should be able to see different result if we do the query. Okay, yeah, almost there. It's going to take some time, but I think we're almost there. Okay, now let's see. We have a binary file, which is CoreDNS. It's already the binary has already been generated. We need a Corefile, which is just one line, right? Okay, let's actually just remove the one line. Okay, that's pretty good. It's up and running. Let's just go into the same machine. Let's just do a dig. By the way, since I set the port number to be 1053, so I'm going to use a -p to talk to a different port number, because the default port number is actually occupied by your system. But that should be easily configurable if you're in a true production environment. Let's just okay, as you can see, that's because it's internal, so that's going to be 1.1.1.1, right? I'm actually pointing to 172, which is a private IP address. Now let's get to my local machine. My local machine, that's actually outside of this cluster, right? So I'm going to dig with a different IP address. Let me see which one. See, that's a result we expect, because I'm actually querying the DNS from my laptop. My laptop is not a part of the build server that's running on the left side. So you see that's 8.8.8. That actually gives you the idea of how to build a plugin. And you can see everything has pretty much packed into like 2 files with like 50 lines of code. That's all you need for having to write a plugin. Okay, so the last thing I want to mention is I already showed how to write a plugin. So if you have interest to contribute, of course, we welcome any contributions. You have several ways to help CoreDNS. You can start on CoreDNS in GitHub. If the company you work for or the institution you work for use CoreDNS and you're willing to share your name, you can certainly add the name to adopter.md. This is also a way to open your first pull request and become a contributor. You can also participate in GitHub or Slack discussions. And finally, if you have an interest, you want to be a maintainer. Actually, if you're a maintainer of CoreDNS, you're also a CNCF maintainer. So that's it's just kind of like a badge. Give you some nice nice fame if you're interested in that. So the way to become a maintainer, the barrier is pretty low. If you can complete a pull request with a significant content. Of course, if it's just a typo, that's not going to count as a maintainer. But if you can add a functionality, that's going to be significant. And there's just one pull request, that's all you need. If you can find an existing maintainer to sponsor you to be a maintainer, then you're part of the CoreDNS maintainer community and also your CNCF maintainer now, which is a very nice thing for everyone. I think that's pretty much it for today's talk. I just wonder, any questions? Anyone want to discuss? Yeah, sure. Yeah.
You mentioned that no upstream no longer need upstream.
Yeah.
Which is that request by the plugin mechanism.
Which one? Sorry.
Wait. You mentioned there is no longer need upstream.
Yeah.
Is that replaced by the plugin mechanism?
I think this is handled automatically. Unfortunately, this part is I'm not very familiar with the way the upstream works. But if you have some question, I think you can open the issue in GitHub. If I think I can find someone to answer your question. Yeah. Okay. Yeah. Any other questions? Yeah, sure.
One question: does CoreDNS support DASDAC？ 就是 IPv4 跟 IPv6的双站是不是支持？
Can you repeat the question again?
Does CoreDNS support DASDAC? Oh, dual stack. Sorry.
Oh, you mean dual stack,
yeah,
IPv4, a combination of IPv4 and IPv6, right? I think that's the question, right?
Yeah.
That's an interesting question. I believe it should, but no one tested that before. But you can open an issue. If it doesn't support, I'll try to make sure it works. Yes. Okay. Any other questions? Okay. Yeah, sure.
I know in the past there is called KuberDNS. What's the relationship between CoreDNS and the KuberDNS?
Okay, we are almost running out of time, but I can quickly just explain a little bit. KubeDNS was part of Kubernetes at one point, and it's actually just a combination of different software. It's it's actually just a small script with DNS MySQL, which is a DNS server written by C, and this is another container. So in order to deploy KubeDNS, you need to have 3 containers. In CoreDNS, we actually combine that into one. At one point, actually, it's a collaboration between CoreDNS team and Google and Red Hat and Kubernetes team. So we collectively decide that CoreDNS probably is a solution moving forward. So we essentially just say, okay, let's introduce CoreDNS as a default DNS server, and let's deprecate KubeDNS. So the KubeDNS will be deprecated pretty soon. Yeah. Any other questions? Oh, okay. One more question.
I run CoreDNS in some offline environment. Then I cannot connect to upstream DNS server. So how can I configure CoreDNS upstream?
Configure CoreDNS
Upstream.
the upstream.
对, when I just I cannot connect to outside the DNS server. Then I configure CoreDNS Corefile upstream. Then
You mean-
upstream. I configure就是upstream config. I cannot 就是I run CoreDNS then report me an error loop detected and the CoreDNS cannot start up.
I can only say I'm not so sure about your question, but if you can, I think you encounter issue when you configure the upstream with CoreDNS. I think if that's the case, maybe I would encourage you to open an issue in GitHub so I can take a look, because it's hard to give you an answer without all the context at the moment.
Okay, thank you.
Yeah. Okay. Yeah. Like I said, if you have any questions, you can always open an issue on GitHub. Both me and Mick probably should be available most of the time. So yeah, hopefully that can help solve some of the issues you guys encounter. Okay. I think that's it. Thanks everyone for coming here. Have a wonderful day and enjoy your stay.